Problem B from this year's World Finals is about building bridge over a canyon. A canyon is given as a polyline that goes from left to right with at most 1000 points with integer coordinates. You may build pillars where the polyline has vertices, and those pillars may be connected with arcs. You pay some cost for every pillar, which is proportional to its height, and for every arc proportional to its area. Now we need to build pillars in such locations that the total cost of the bridge is minimal and the arc may not intersect with any point in the terrain, though it may actually touch vertex. That's allowed. This is a dynamical programming task. What we want to do, we want to figure out for every pair of points on the terrain if it's possible to build arc between them. To compute this efficiently, we take all possible starting points of an arc, and then we compute how large this arc may be for every if it needs to cover some number of points. In particular, if we know that there is a point in certain location, we find arc of such size that it touches the terrain and the location of this point. Then, in order to find if the arc is possible between 2 points, we need to make sure that the size of the arc that is required to build it between 2 points is not more than any of the values that we computed for points on the terrain between them. After we do that, we can just do a simple dynamical programming on a graph that goes from left to right, with cost of each edge being the cost of producing an arc between the points and adding a pillar at a given location. That's it.